Hey, what's up everyone? Welcome to the Rocking Data Science channel, where you can find videos about Python programming, machine learning and data science in general. The goal in this video is to cover a few topics over the NumPy and try to explain what is NumPy. The NumPy is a fundamental package for scientific computing with Python. It was designed to be really efficient, and I will show you in a few seconds what I mean. And what is an array? An array is a grid that contains a few values, one or more, and they are always the same type. Before starting, let me just show you one very important and useful thing that I think you enjoyed. Let's go. What I have to show you is this cheat sheet for NumPy. It is very useful because it has all the basics that you need to start understanding the NumPy. So I recommend to save this cheat sheet on your computer. You can find the link below in the description. It is in the Rocking Data Science repository in GitHub. Before starting, let's import our NumPy library. And for that, you can do import NumPy as np. Pretty much everyone uses np to refers to NumPy. And now we can check how fast is NumPy. And this is a really interesting exercise because here you will be able to see the difference and to see how much efficient it is. For that, let's create a NumPy array. Let's say a NumPy array 1 with np arrange with 10 million integers. And now let's create a Python list with also 10 million integers with a range of 10. Now let's multiply each one by 5 and see how much time it will take to do the operation. And for that we need to use the time function so we can see how much time it will take. And before running this one, I will do another one for the list. Python list 2, it will be equals to, let's say, x multiplied by 5 for x in p list 1. And now we will multiply and see how much time each one will take. And as you can see, the NumPy is really faster than pure Python. And that's crazy. The NumPy is so efficient, it is much more fast. So imagine you are dealing with a large number of numbers, and instead of using a list, it is more useful if you use an array. So now go back to your cheat sheet and let's check one thing. You can have NumPy arrays from 1 dimension with only 1 line, 2 dimensions with 2 lines, let's say, and 3D dimension. In this introduction, we'll be focusing on 1D array and 2D array. Let's create our first 1D array, and for that you can use this. Okay, so let's create 1D array. X equals to np.array, that's how you create an array. And then you open the parentheses, then square brackets, and you write the numbers you want. 1, 2, 3, 4, and 5. So, and here is our first 1D array. Now, if you check the type of this variable, type X, you'll see that you have a NumPy array. And we can also check the shape of our array. And here you can see that when you check the shape, you have the number of values that it contains. Now we can also check some slicing in our array. So for example, if I check the x0, I'll have 1. If I check the x3, I'll have 4. And you can do this for several index inside the array. So x4. And if you try to check fx6, for example, you have an error because the index 6 is out of the array. So in that case, let's stick with 4. It goes from 0 to 4. And besides slicing, we can also change the numbers inside of the array. And for that, let's select the index 4, which is a 5, and let's say that it is equals to 10. And after doing this operation, let's check our array, and we have 1, 2, 3, 4, and 10. Very simple stuff using 1D array. Now let's go to 2D array. To build a 2D array is also very simple. Let's say that we have y equals to np array, and then you open parentheses and then square brackets, and here you can insert another parenthesis and you write 1, 2, 3, and then you put a comma, and then again 101, 102, and 103. Think of it like this. So you have a two-dimensional array, and here if you print y, you have this. So it is the same thing, you just need to be comfortable while you're writing your code. And if I check our shape on our 2D array, you'll see that you have a 2x3 shape. So in this case, in the 2D array, the slicing can be a little more complex, and also in the 3D array, but let's see how can we slice into 2D array. So for example, if you want only one row, let's say the 0, the first row, you have 1, 2, 3. Or if you change it for 1, you have 101 and 2 and 3. If you want a specific element or value inside the two-dimensional array, you have to specify it. So let's say that you want the y, you want the number 1. This one is very easy, 0 by 0, and you get 1. If you want the 2, you say you want the 0 row and the number 1 in index, and you get 2. Now, for example, for the second row, you have, let's say, 1 by 2, and you should get the 103, which is the last number. In this case, there are also another way to check the last number of counting from the last number, which is very simple. So you write y and then -1, -1. And you get 103 because you start counting from the end. If you do -2, you'll get 102, and the same for -3. So it's very simple, but you only need to count from the end, and 0 doesn't count in this case. So now let's check some things or some functions to create an array. With np.random, you'll get let's say 2 by 2. You'll get random floats in the shape that you choose. But let's do an arrange. It's also very useful, and for that, let's say that you have u equals to np arrange, and here you have to define where you want to start and where you want to finish and the number of steps. So for example, let's start at 0 and let's finish at 50 with steps of 5, and this way we will get 0, 5, 10, 15, 20, and therefore. Now let's jump into the Numpy operations. This is very simple, and we already saw it when checking how fast is Numpy. So let's use the u array and do a new one where we'll be multiplying the u by 10. And when you do operations like this, it will apply the operation to all the values inside the array. So, and when you do this, after pressing enter, you can see that you have 0, 50, 100, 150, and therefore. And this operation here, where you apply an operation to the entire array, is called vectorization. And it allows us to do a batch operation into the entire array or data without a single loop. And that's one of the reasons that makes the Numpy so efficient. And now, when you have arrays of the same size, you can also do an operation between them. So let's check a new array and multiply u by u10. New array. And here you can see that we did a multiplication between the elements of each array. And this is possible because they are equal size. Now let's work with arrays and strings. And to build an array string, all you need to do, let's say array string is equals to np array. And now instead of using numbers, you can use strings. For example, 2000, 2020 and 2040. And here we have our array string. And whenever you are in a situation like this, you can create a new array with a different type. So let's say, for example, here array, it's equal to, and we copy this one, and then you write as type int. And now if you write here array dot dtype, we'll check that you already have an integer here. And by the way, if you write here array, you'll see that now you have a simple array with integers. Now let's talk about universal functions. And if you open your cheat sheet, you can see that you have a lot of functions here in the middle. So we'll use a few of them to show you how can you apply them. To keep it simple, let's use the same array that we've been using. It's not defined. Well, this array is only u, lowercase. To keep it simple, let's use this array that we started. So, for example, we can apply the square to this array, and we'll have it apply for every number within the array. You can also use the log, so np log, and then u. And also we can do multiplications with multiply, and then you pass two arrays inside of this. So let's say u and I think x. Yeah, okay. They have different shapes, so you can't use them. But we can u and u10. So, and basically it will do the same that we did above. So now you can also do some data processing. So let's write data processing. And with this you can do, for example, the sum of every number inside of the array. So np sum of u. And it will sum every number inside of it. You can also get the mean of u. It is 22.5. And print, for example, numbers like np.minimum of u and np.maximum of u. And you have 0 and 45 for this array. It is useful to understand better the array you're dealing with. Imagine an array with 10 million values, so it is interesting to understand what you have in there. Then you can also sort. In this case, let's build another array, so d equal to np array of 3, 4, 2. And now let's, for example, compare. Let's do a print for the original one, and it is d. And then let's use another one for the sorted. And then use np.sort, and then between parentheses the array that you want to sort. So, and here you can see that our array was sorted. So now we also have unique. You can find unique values inside of array. So let's build an array, the f array with np array. And this one should have several numbers equal. So, and when you do this, you can use np.unique, and then you put the array, and you'll have the unique values inside of your array. And now the challenge that I have for you is to take the cheat sheet and build a 3D array and try to apply a lot of things of that cheat sheet to the 3D array. You will learn a lot by doing it yourself instead of watching this tutorial. If you have any question while doing that, leave a comment below and I will help you. Don't forget to smash the like button if you enjoyed this video, and if you are new here, consider subscribing. Now, if you want to learn more about Python for data science, pick this playlist here. and it has a lot of videos and tutorials for Python applied to data science. If you want to pause coding tutorials, make sure you check this playlist here where I talk about machine learning. It is very clearly explained and I hope you enjoy it. I hope to see you around. Cheers, bye.